A very good morning to my dear class 12 computer science students. Beta, we were reading chapter number 10, that is communication and networking concepts. So let us continue with a new topic of this chapter, that is network devices. So what are network devices? These are actually the hardwares that are actually required to make the network functional properly. Okay, so these are the specialized hardware devices that are playing some significant role while we are accessing the network or while we are working on the internet, right? So let us now start discussion of these devices one by one. The first device is the modem. So modem is actually required to convert the analog signals to digital signals and digital signals to analog signals. So now whenever we are whenever we are dealing with the telephone lines, in telephone line the signals are in the form of analog, okay, but in computer they are in the form of digital signals. So there is a mismatch. Okay, so when the signals they are coming from this analog coming in the analog form, and when they are entering inside the computer, they must be transformed into the digital format, then only the computer will be able to accept it. Okay, so the process during which the digital signals are converted into analog signals when they are coming out of the computer is known as modulation. Okay, so the signals when they are trying to enter from the outside the computer to inside of the computer, then they have to be transformed from that analog signals to digital signals. Okay, so the process of conversion of analog signals to digital signals before they enter inside the computer is known as demodulation. So modulation is the process of converting the digital signals to analog, and demodulation is the process of conversion of analog signals to digital signals. Okay, you can remember it like DAD. So D is for demodulation, A is for analog, and D is for digital. Okay, in this way you'll not be confused, so remember in that way. Okay, so next is the types of modems. So modems, they are very much essential whenever we are in need to get connected with the internet. We must have a modem connected to our system. Okay, so there are two types of modem. One is your internal modem, second is your external modem. So internal modem is basically present or fixed inside the computer. Okay, so when that modem is existing inside the computer, it is known as internal modem. And when the modem device, so this is your internal modem which is existing inside the computer, and this is your external modem, okay, that you are connecting outside the computer. Fine, so this is very important. Now next device is RJ45 connector. RJ stands for registered jack. Beta, wherever you are finding the short forms, please note them down somewhere because they are very important from the point of your CBSE board exam. Okay, so for what purpose we are using this registered jack? Okay, I'll explain you, but before that let me explain the basic structure of it. It is basically an 8-wire connector, okay, which is used basically to connect the computers on the LAN. So if you want to connect computer to the LAN, so you must have one end of the wire that looks like this. Okay, when this will be inserted inside the slot of the CPU, so your system will get connected to internet. Okay, so you know the LAN, Ethernet. What is Ethernet? Ether is a LAN architecture, okay, which is basically supporting the topology like bus or the star, and it also supports a data transfer rate up to 10 Mbps. Fine, so RJ45 connector, it is a connector only which is attached to one end of the wire. Okay, so this particular connector is known as RJ45 connector, and it is having 8 wires in it. Means the 8 wires are inserted into it, and then this connector is inserted into this RJ45 jack. Okay, so next is your interface, network interface card. So when you are not connected, when your computer is not connected with the internet, means your computer is standalone. Okay, so when your computer is not connected with internet, then your computer is known as standalone computer. But when you get connected with the internet, what happens then? Your computer gets transformed to a workstation or a node, we can say. Okay, so when we are connected with the internet and we want to access the network things that are available there, okay, so we need an interface that helps us to create or establish connection with the network. So for that purpose we use network interface card. As the name itself is suggesting, it is creating an interface of the computer with the network. Okay, so every NIC is attached to a workstation and it is having a unique identification number, and this NIC unique identification number is known as MAC address. Okay, MAC stands for media access control address. Media access control address. Okay, this is also known as your physical address, and this is of 48 bits. Okay, or we can say 6 bytes, and every NIC is having a unique physical address that cannot be allotted to any other NIC. Okay, so it will allow a particular computer to have a corresponding logical ID in correspondence to it. Means in correspondence to this physical address, one computer will get a logical address. Okay, so who assigns this unique physical address to this NIC? The NIC manufacturer only. So when it is being designed by the manufacturer, a unique physical address is given to a NIC card. Okay, and this NIC card is many times known as terminal access point, or sometimes it is also known as NIU. NIU stands for network interface unit. So NIC is called as terminal access point, that is TAP, and it is also called as NIU, that is network interface unit. Okay, so let us share the next concept. See, actually I have told you that there are 6 bytes in your MAC address. So first 3 bytes are basically the manufacturer ID, and rest 3 bytes are the card number. Okay, this is the code for the card number. Okay, and that is actually unique. Fine, next is your Ethernet card. Ethernet card is just like your NIC card, or we can say it is a type of NIC card. NIC stands for network interface card, we have just discussed. Okay, so this particular NIC card is required for the establishment of the Ethernet, and that is in actually the LAN architecture. Okay, that supports Ethernet, uses basically bus topology or star topology. That topologies we have already discussed, and it may support the data transfer rate up to 10 Gbps. Okay, so the computer that are a part of Ethernet have to install a special card, and that is known as Ethernet card. Now this Ethernet card can have connections with coaxial cable also and twisted pair cable also. So if you can see, this is your Ethernet card, and it is having slots for RJ45 connector and BNC and AUI. Now what is this RJ45? We have discussed registered jack 45. Okay, and next is your BNC. BNC stands for the full form is given here, that is Bay 1 Nil Console Man. Okay, it is also a type of connector, like we have RJ45 connector, we have BNC connector also, and we have AUI connector also. AUI stands for attachment unit interface. Okay, so this RJ45 connector was having 8 pins, but this AUI connector is having 15 pin. Okay, it is also meant for the same purpose, that is for getting it attached with the Ethernet cards. Okay, but whenever we are dealing with different types of cables, like if we want to deal with the coaxial cable, then we will need BNC connector. Okay, this is the shape of BNC connector. Okay, sometimes we may require AUI connectors, so it is a 15 pin connector. So according to the connector you are using, you will be using these ports. Okay, if you are using RJ45 connector, then you will be inserting it here. This is the jack for the RJ45 connector in the Ethernet card. I hope it is clear. Okay, so they all are meant for the similar type of purpose, but their basic structure may be different. So according to the equipment or the thing you are having for getting connected with the internet, you may select any one of it. Okay, so you are having three options. So next is your so it is basically telling here that you may use coaxial cable, twisted pair cable, or fiber optic cable to an Ethernet card. You can connect via any of the guided medium. You can use your coaxial cable, you can use a twisted pair cable, or you may use fiber optic cable. So according to your availability, you may select the mediums and accordingly the jacks in the Ethernet card. Fine. Next is hub. So what is hub? Hub is another network device that is basically required to connect several computers together. Okay, so hub basically contains multiple independent computers that are connected together with the help of a device that is known as concentrator. So concentrator is basically a device that is required to connect various computers together, servers together, peripherals are input and output devices, we can say. Okay, we are having two types of hub. One is your active hub and second is your passive hub. Okay, so active hub is actually amplifying the signals. Amplifying means with the passage of the distance, means as the distance increases, like the source is transmitting something, like one server is client is sending a request to someone, or we can say if we are transmitting our signals to our friend. Okay, I am transmitting some signals to my friend, so these signals have to travel the path. Okay, if my friend is far away, the signal may go weak with the passage of travel in the air. So we need to amplify the signals. We need to need to generate the strength of those signal again. So we can use either repeaters or amplifiers to amplify the things, the signal quality we want to retain, so we can go with the repeaters. Okay, so repeaters are actually repeating the signals for a longer duration, or we can say for a longer distance, so that the quality of the signal may not get deteriorated. Fine. So passive hubs, they are not doing any amplification. Active hubs, they are doing amplification. So if the distance is more, we'll go with active hub instead of passive hub. Okay, next is switches. So as we have hubs with us, we have switches with us, so they are very important. So what is the difference between switch and hub? I'll let you know, but switch is also doing whatever that hub was doing, switch is also doing, but there is certain difference in the functionality that I am going to clear it now. Before that, I just want to tell that switch is responsible for filtering. So what is that filtering? Means it will see to which that particular signal has to be transmitted. Okay, so actually hub is not intelligent. Fine, it is a dumb terminal. So it is not what it is doing, whatever signal it is taking up, it is transmitting that signal to all. Fine. So there is a problem then. So multiple computers are receiving those signals, so that is not good at all. If something has not to be given to me, then why it is coming to me? So it creates unnecessarily traffic on the network. So unnecessary traffic if we want to avoid, and one another benefit that switch is giving, that it offers us to send and receive the information at the same time. Okay, but in hub we cannot send or receive together. Okay, so this is another one difference, that switch allows us to receive and send information at the same time. Fine. And but switches are expensive in comparison to hub. Okay, and we have another difference, that hubs are repeating the signals. Okay, but the switch, they send traffic only to a appropriate connection. Like if I have to send data to my friend, so in between if others are sitting, though my data will not go to others, it will directly come to my friend only. Okay, so switch is intelligent. It is not transmitting my data to anyone else because it knows the address of the recipient, so it directly goes there. It is just like you are having a smart postman in your locality and who knows the addresses of the recipients, and he goes only to the house where the letter is to be delivered. Okay, but your hub is like that dumb, you know, your dumb postman who is not aware that where the address, which address is existing where, so it is going to all the houses and asking whether it is your letter. Okay, so we prefer switches in comparison to hubs. Okay, and one more thing is that hub basically shares the bandwidth. So bandwidth is that through which the data transmission has to take place. So if the bandwidth is more, the data transmission will be much more. Okay, so it shares the bandwidth, but switch does not share the bandwidth. Okay, in nutshell we can say ki switches, they are intelligent and they do not allow sharing of the bandwidth. Okay, and we can send as well as receive at the same time, and they are expensive. Switches are expensive. So I have cleared you the difference between the switch and hub. I hope you have understood it. Okay, so now what is repeaters? So repeaters, they are just like the amplifiers. Okay, so they are amplifying the signals. So we can say it is a network device that amplifies and restores the signal for a longer distance transmission. Okay, so it is amplifying and then rebroadcasting it. Fine, so that we may be able to maintain the quality of the signal for a longer distance, and it removes the noise also, so that the quality must be retained. So there are two types of repeaters, one is amplifier and second is signal repeater. Okay, next is bridge. So what is bridge? Bridge is actually a device that is connecting two networks together, like two LANs together it can connect. So bridges, they are smart enough to know that which computer are on the which side of the bridge. So like we are connecting two networks together. So like if I am residing in one network and my friend is residing in another network, what is a network? Network is a collection of computers. Okay, like in one building we have some computers, in second building we have some computers, and we want to send a message from one computer in one building to another computer in second building. Okay, so these are two different networks, two different buildings are having group of computers, like, and we want to connect them together so that they may share information. So which device will be needing? We will be needing a bridge. Okay, so bridge they are actually smart. Okay, they know which computer is lying there and how to handle these networks so that they may communicate or send information to each other. Okay, so if the communication is possible between two different two networks, then it is possible with the help of bridge. Okay, so now what is router? Router is just like bridge only, but it can handle different protocols. What are protocols? Protocols are the set of rules, like we have read TCP/IP protocol in previous lecture. So TCP/IP is basically helping us to break down the data. We have read the complete packet switching technique. In that we have read that TCP was doing the breaking down of data, and then it was reassembling at the reassembling the data in the same order at the receiver's end, and IP was what it was doing, it was taking the data from one end to another. Okay, so TCP was breaking and assembling the data, and IP was taking that data from one source to another. Okay, source to the destination. So what is a router? Router is actually a device that is just like a bridge, but it can handle many protocols along with it. So a router is basically responsible for forwarding the data from one network to different network. Okay, so like if you are sending data and there comes a router that is sending the traffic from one network to another, and if it is not knowing the destination where that particular packet has to go, so what it will do, it will hand over the it will hand over that data to another router. Okay, with that knows the destination. How it happens? Because like I am trying to send data to a friend who is in other country, so the distance is too large, so there will be many routers in the way. So the main actually the sending from where the sending operation has started, that router, and where it will end, means near to my friend's destination, that router, actually they are the main ones who knows who is transmitting it and who has to receive it. Okay, so in between the routers will be there, they are not aware, they just know to which router it has to be sent. Okay, like in between the way there are 5 routers, so the first router and the fifth router are the main routers that has to take up the data from the source, and the fifth router is the one that has to deliver the data to the destination. So in between, if we are having few routers, so those routers, they are not aware about the destination, they are just passing the data of the data that has been given by the one router to another router. Okay, so that the final router may send the data to the required destination. Okay, fine. So for that they are having, for doing this type of task, they are maintaining a routing table. Okay, so this routing table ensures that particular packet is traveling to a proper path, so that it may reach the destination. And if any failure occurs in between, then these routers, they use alternate path to get that data to the respective destination. Okay, so a router basically works on the logical address, that is also known as IP address, and the bridge, it works on the physical address, that is your MAC address. MAC address we have just discussed. Okay, in correspondence to the physical address, every computer is assigned a logical address. Okay, so the router basically works on the logical address, that is also known as IP address, and bridge works on the physical address, that is also known as MAC address. Okay, like you have an admission number in your school, but when you are going to another school, they are assigning for competition, let us say you are going, they are assigning some registration number to you there. So in correspondence to your registration number of the school, or admission number of the school, you have been assigned a new registration number for that competition purpose. Okay, so this is your school admission number, and this is your that admission number, or that registration number that has been given for the purpose of competition. So this is the address that has been given to you for the purpose of for working on the internet. Okay, this is the actual address that will remain the fixed, because MAC address cannot be changed, but logical address, it keeps on changing. Okay, so what is now gateway? Gateway is another device that is actually connecting dissimilar networks. Like here we have not a LAN, and here we have another side we have WAN. So if we want to connect LAN with WAN, so what we will use, which device will use? We will use gateway. So gateway is basically required to connect two dissimilar networks together. Okay, so if you are working in home, then gateway is like your ISP. ISP stands for internet service provider. It's an organization that is giving you the internet connectivity, like you have BSNL, MTNL, you have Jio, and many others. So ISP is your organization that is giving you connectivity of internet against a fee for a particular period of time. Okay, so when you are at home, your gateway is like your ISP that is connecting you with the internet. Okay, when you are in an enterprise, then gateway is like a proxy server. Proxy means it's a server that is not actually there. Okay, like if you say proxy of your friend, means your friend is not in the class, but you are saying present for your friend, so that is a proxy. So server is not there, but still you may feel that some machine is there that is acting like a server. Okay, so in enterprise, gateway mode often act as a proxy server and a firewall. So firewall is basically required to stop the unauthorized access into your network. Okay, so your gateway is associated with two devices. One is your router and second is your switch. Okay, so it works in combination with the router and switch. Okay, so now next is your Wi-Fi card. So Wi-Fi card is basically required to get yourself connected with the internet. So if you want your computer to get connected with the internet, you must have a Wi-Fi card, and it can be external, it can be internal. Okay, so you can see And what for desktop computers, PCI Express, these are the Wi-Fi cards that are being used. Okay, and I told you that they are benefit of using the Wi-Fi card, they can receive and transmit the internet signals, so they are acting as both receivers and transmitters. Okay, so now let me give you a checklist of the components of network devices. So if you are using a small LAN for a building, so you must have client computers there, server should be there, hub should be there, cabling you must have. Okay, network operating system you must have. Okay, for connecting offices and the departments, so you will have you need to have clients, servers, hubs, switches, cables, network operating system, and routers also you may require. Okay, for connecting dispersed office means if the office is distributed at various locations. Okay, like one company is having different centers at different locations, in that case you need to have clients, servers, hubs, switches, routers. Okay, access server should be there, cables should be there, WAN connectivity should be there, network operating system should be there. Okay, so now this is a very important question that comes in your exam, so you must listen to it very carefully. So where to place a server in the network, this I have told you earlier also, this is very important, so kindly listen to it very carefully. So you can be given like the data like this, like in building A we are having 120 computers, and building B we are having 20 computers, in building C we are having 25 computers. So a rule is there, like 80-20 rule. It says in a properly designed small to medium sized networks, 80% of the traffic on the given network segment is local. Okay, 80% traffic will be local. Okay, and not more than 20% of the network traffic should need to move across the backbone. Means like if you are having 3 buildings, so if you set up your server here, so maximum computers are here only, so you will get 80% of the traffic from this building only, and 20% you will get from the other buildings. Okay, so where you should set up your server, you should set up your server in building A. Okay, so wherever you are having more number of computers, the server should be set up at that location only. If you are not doing this, then you are unnecessarily increasing your expenses. Why? Because let us say you are setting up your server in this C building. Okay, so 120 wires will get connected, so this signal has to be transmitted to building C. 120 computers, they will try to get connected to the server that is present in building C. If you place your server here, what will happen? Only 25 and 20, so these 45 computers will only try to get connected with the server that is here. So in nutshell, what you have seen, the overhead of placing a server where number of computers are less will be avoided if we are putting the server at the place where we are having more number of computers. So the question comes, in which building you will set up your server? Your answer should be the one which is having the maximum number of computers in that area. Okay, so it is also saying building A as the host, maximum number of computers. Fine. So this is of 1 marks question, every time the answer will remain same. So now you need to focus on certain points, like choose twisted pair cables. When you need to choose this guided medium twisted pair cable, when you have low cost setup. Okay, you can't spend much. Okay, when you can't have any professional to install the setup, so if you want easy installation, then you can go with twisted pair cable, but it will not offer high speed. Okay, you will get low data rate and a limited bandwidth of up to 1 megahertz only. So transmission will also be short. So keeping these things in your mind, you can go with twisted pair cables. If you are ready with these types of things, you can go with twisted pair cable. And what the other things it is offering, that it will support the analog transmission, and for that you will be in need of amplifiers. Okay, and then amplifiers, they will go from 5 to 6 kilometers. So if you are dealing with the digital transmission, then you will be in need of the repeaters, and they will help you to transmit signals from 2 to 3 kilometers of range. okay, and they will be susceptible to noise and interference. So if you choose coaxial cable, then following things you must keep in mind. So coaxial cable works good when we are working with the TV or aerial TV or the cable TV. If the distance is, it means you have to use you have to take the distance longer, and you need to support then 10,000 voice calls or so, then you may go with the coaxial cables. Okay, so short distance computer systems, if you are working with, then you can go with the coaxial cable, and if you are dealing with the LAN networks, LAN area, local area networks, then you can go with the coaxial cables. Okay, what else you need to take into care? You need to use, if you are using analog transmission, then you have to attach amplifiers, and that will allow your signals to get traveled to 5 to 6 kilometers. Okay, and for digital transmissions, repeaters are required, and they will take your signal up to 1 kilometer only. When you are selecting fiber optical cables, then you have a greater data transmission capacity, and it will offer you data rates up to 1 GB, hundreds of Gbps. Okay, there will be a secure transmission, and the cost will be high, so you should be mentally prepared for the cost related issues. Okay, so you will be having a, means you need to set up more or less number of repeaters, because they can they send the signal quality up to 10 kilometers. Okay, next is your when you are dealing with the radio waves, so you can go with the longer distances, but and next quality they you will be next benefit you will be having, that they can penetrate the wall or the building, and this transmission will be omnidirectional, means you can transmit the signal in any of the direction. But the problem is health hazards, they are involved in this type of transmission. So when you are working with the microwaves, the problem is that you need to transmit the data in a straight line only. Okay, though it is cheaper unguided media, but your signal quality may get deteriorated when your signals, they are not traveling in the straight line. Okay, next is you will need repeaters after the 30 miles. Okay, and these microwave signals, they work in a line of straight transmission, means they work in the straight line only. If any obstacle comes, that absorbs the signals. Okay, next, if you are going with the satellite transmission, you will be able to cover the large area of the earth. Okay, and you may use it for various purposes. Fine, important, it will be expensive, you need to install towers and repeaters. Fine, there can be interference when the weather is not clear or aeroplane is passing. Okay, so these are the problems you may face. Next is when you are dealing with the infrared waves for the transmission, you are not required to acquire the license, and problem is that it cannot penetrate the solid walls. So you must keep these things in your mind. Now let us try solving this particular problem. So they have given you 4 buildings, 1 2 3 and 4 buildings, and they are saying ki suggest and justify the placement of the repeaters and switch or hub, where what should be placed. Okay, so it is saying the placement of the repeaters, it should be done between the building 1 and 4. Why? Because if the distance is more than 100 meters, then repeaters are required. Okay, if the distance is more than 100 meters, your repeaters are required. Like between one building number 1 and building number 2, you can count 70 plus 35, it is 105 meters. So beyond 100 meters, if you want to transmit your signal, then in between these you must have repeaters. Okay, where you can place hub or switch when you are having more than 2 computers. Okay, then you need to connect them together. For that you will need hub or switch, but nowadays we are using switch, we are not using hub, we rarely use it. Okay, so everywhere, like here 10 computers are there, there are 30 computers, there are 15 computers. So in all these 3 buildings you should do correction, it is building number 3. In building 4 it is not required, because more than 2 computers will be there, then only will be needing it. Okay, so now let us take another example. So this example is giving showing different buildings, and they are showing the distances also, and this data is showing that how many computer this particular building is having. So first question is that how many means you can read it out that this pro building is having 55 computers inside it, and the distance between the gray cell and the pro is 50 meters. In this way you can read this complete diagram. So what is first question is that suggest the possible cable layouts for the buildings. Okay, so what are the possible layouts for the buildings? One is you can see how you can get connected. You can use the star topology where to you can place the server. Firstly you need to see this. So number of maximum computers are there in this gray cell only, so your server should be this only. If this is your server, then you can use this star topology to connect all the computers together to this. So it can be structured like this, all the computers they are connected to this only. Okay, and next is your this type of topology giving appearance of the bus, so you may connect all the computers like this only. So when you are connecting the things, the layout when length of that particular cable that you will need is 190. How it has been calculated, you can count this to this 50 kilometer, then 30 kilometers. Okay, if you are connecting this, then 65, then this 45. Okay, so every computer has to be connected to the server only, rest connections we will avoid. So we will not put this, we will not put this, sorry, this we will have, we will not put this, ye wala we will remove, this one we will also remove. So we will just keep the connections that are important, and you can count the length of the cable they have already given, and here also you can add the length of the cable, that will be 155 meters, and here it is 190 meters. Okay, so next question it is saying where to put the server. So 80-20 rule says that this should be mentioned in your answer. 80-20 rule. Okay, it says that where are the maximum number of computers are there, server should be there. So maximum number of computers are in gray cell building. Okay, next what is saying that suggest the cable type that must be used. So like we were having thick net cable and thin net cable. So thick net coaxial cable, actually if your the length of the network is means it is more than 500 meters, then you should go with it. So if you'll count it, okay, so total length is beyond 500, that is so we have to go with a thick net cable. So last is the management wants that the network traffic should be minimized. Okay, we want to minimize the traffic. To traffic, you know that if we are using hub, so it is unnecessarily transmitting the signals to all the, means like it's a dumb postman who is going to every house to ask whether it is your letter. So we will not use hub at all, right? For this network device would be used out of these following, and why. So they are saying if you want to minimize the network, you should stop the data broadcasting. Okay, so for this we will go with the bridge. Okay, so we know that hub is broadcasting the data, it is sending the data to all, it is broadcasting, so we'll not go with hub. And best choice is your bridge, because bridge does not broadcast any data and it sends the data directly to your destination. So this is the best choice. Okay, so our next topic is network protocols. So this network, what is a protocol? Protocol is basically set of rules. Okay, so we'll be discussing this particular topic in our next session in detail. Thank you so much.